Hey y'all, today we are going to be talking about mistakes. You're going to see me make a ton of mistakes this year, and you are going to be okay making mistakes too. And today's main objective is that you are going to find and learn the different types of mistakes. There are specifically 3 different mistakes that we are going to talk about. Before we get into that, here are some reasons why I want you to be okay with mistakes. When I think of the word fail, I think that stands for first attempt in learning. You can't learn and be good at anything until you first tried it. And when you first try something, you will make a mistake. Okay, there are some times where you're just automatically good at something the first time, but for the most part, you are going to be making mistakes. And math is one of those things that if you're trying it for the first time, you are going to make some mistakes, and that is completely okay. And we're going to spend a whole day on this next week learning about what actually happens in your brain when a mistake happens. So, the big thing I want you to know is that I am good with mistakes. I can't have you learn math without making mistakes. And so I'm okay with mistakes. What I want to teach you today is kind of the differences between the different types of mistakes. There are 3 main big types that we're going to talk about in math anyways. There's a careless mistake, a computation mistake, and a conceptual mistake. And I made it really confusing because they all begin with C, right? So that's might be a little tricky, but I'll talk through them with you, and you'll be able to see the differences between these 3. So the first one I want to talk about is a careless mistake. These mistakes happen mostly when you are just not paying attention or you're working too fast. And I just realized that that 2 was not the correct 2, so I'm going to fix that real fast. Oh my gosh, I totally just made a mistake. And just realized that. Okay, so obviously I make mistakes, but I'm okay with them. So a careless mistake is when you are copying a problem to work on it and it was a 7 and you wrote an 8, or some where you just write the wrong number down. So of course your answer is going to be wrong. Another careless mistake is when you have really sloppy handwriting and so you make a 6, but it's really sloppy and so it looks like a 0, and so then that messes up your whole problem. That's careless. That's just not being careful enough. Okay, or if you're just not following directions and doing your own thing, you're going to end up with some careless mistakes. Here's an example of a careless mistake. Here we see 231 plus 17. Someone wrote down 231 plus 17, so they wrote down correctly. But if we see this poor handwriting, when they went to then add it, they did 1 plus 7 is 8. And then here's 3. And then 2 plus 1 is 3. So they ended up with something completely wrong because their handwriting was very messy. And that's what's called a careless mistake. They would not have made that mistake if they would have been a little more careful. So what do you do to avoid careless mistakes? Very, very simple things. Biggest thing you can do is just slow down. Okay, check your work. Make sure you wrote the numbers correctly. Okay, circle important information so you don't forget to do that important step. Okay, so that's careless mistakes. The next mistake is called a computational mistake. Computational kind of sounds like a computer, right? So when you are making a computation mistake, it means you're making a mistake when your brain is like the computer part of it, when you're adding, subtracting, multiplying, or dividing. If you make any of those mistakes, when you add something wrong, you subtract something wrong, you divide or multiply incorrectly, that's called a computation mistake. The hard thing about these computation mistakes is if you're dealing with like a multi-step problem and you added incorrectly at the beginning of the step, the whole rest of the problem is going to be wrong. So you want to try and avoid these computation mistakes by double checking your work, right? Oh, here's an example first. So my first example of computation is a computational mistake. We have 231 plus 17 again. We set it up beautifully, right? 1 plus 7 is 9, 3 plus 1 is 4, 2 plus nothing is 2. The computation mistake is right here. 1 plus 7 is not 9. So that is an example of someone making a computation correct. They were very careful in setting it up. They just computed wrong. 1 plus 7 is not 9, it's 8. Okay, so how do we avoid this mistake? Again, we slow down and we double check our work. So before moving on to the next problem, we just go over it again really quickly. 1 plus 7, 9. No. 1 plus 7 is 8. And then you can erase it and put an 8 before moving on. And it's as quick as that, checking your work, okay? Then we'll check 3 plus 1, yes, that's 4. 2 plus nothing is 2. Good. Maybe check, yep, I wrote it down correctly. Awesome. You don't have a careless or a computation mistake. Okay, so the last mistake is called a conceptual mistake. If you understand the concept of something, it means you really understand it in your brain. And you understand why we're adding. You're understanding why we multiply when we have a set that happens over and over again. That's conceptual understanding. This mistake is a little harder to identify and to realize that is the mistake, but it's also the most important one to catch it and correct it. Let me give you an example of a conceptual mistake. So here's the problem. It says Sally and her friends have a bag of candy with 24 pieces of candy. They decide to share the bag equally. If they each get 6 pieces, how many friends are there all together? So if this student just took 6 and 24 and times it together, it shows that this student doesn't really understand what she should be doing with those numbers. She doesn't understand that when they decided to share the bag equally, they're not multiplying it by the amount by 6. They're sharing it. They're dividing it between 6 pieces between all the friends, right? So it's actually a division problem. So even if they did 24 times 6 and they got it correct, that's still a mistake, right? It's not a computation mistake because they did the computation correctly. It's a conceptual mistake because they didn't know that they were supposed to divide and not multiply. Okay, here's an example of a conceptual mistake. Here's the same problem, 231 plus 17. So they conceptually didn't even understand that they're supposed to, that it helps to line up, right? The two numbers, so you have your ones, tens, and hundreds. Conceptually, they didn't understand it, so they just rewrote it the same. And then they did 2 plus 1 is 3. 3 plus 7 is 10. And then they just had a 1 here that they stuck on the end. Okay, your conceptual mistakes are sometimes the answers that are like way off because you just have no idea what to do. Whenever you're looking at a question and you're like, I have no idea what to do, you're going to make a conceptual mistake. What do you do when you've made those mistakes? Well, I have these videos that you can rewatch again to see if it clicks that second time. I have your notes that you can look at. You can ask help from a classmate or assist teacher behind there. You can get help from us so that you can see and we can talk you through it. If I didn't do enough explaining in the video, then you can get more explaining from me or more explaining from a friend. And with that, that is going to help you not make those conceptual mistakes. Okay, so last thing I want you to remember, mistakes make your brain grow. I want you to make mistakes. That means that you're trying. I want you to try, which means I'm going to accept the mistakes, of course. Do not regret your mistakes. Just know that, okay, every time you make a mistake, you figured out how not to do it and your brain got smarter. Okay, so you'll notice that with a lot of these, how do we not make conceptual? How do we not make computation or careless mistakes? I said, just check your work. So I want to teach you now how to check your work. Okay, so the first couple of things that I want you to do, one of my most favorite ways to check your work is to actually grab the answer key and check your work with the answer. Yeah, you heard that right. I'm giving you answer keys this year. And what you do is you take the answer key, you hold it up next to your answer. If your answer is 427 and the answer key is 427, boom, move on. Next problem, 340. The answer key says 342. As soon as you get to that point, this is what you're not going to do. You're not going to erase the 0 and put a 2 and then move on, right? No, you made either a computation or a careless mistake. You're going to figure out what mistake you made. So you're going to look through your problem again and you're going to see, I did this wrong. Then you can erase it and put the 2. So when you are checking your answers, it's not just erase everything and write all the right answers. It's look and find what mistake you made if your answer doesn't match up with the answer key. That's one of my favorite ways to check your work. Okay. One other thing you can do is use the opposite operation. So if the question is 54 plus 6 and you wrote down 60, well, you can check that by doing the inverse. Since it's addition, I can do subtraction, and 60 minus 6 is 54. So I know that I did it correctly. Okay. Another thing you can do is redo each problem on a separate piece of paper. This is really good if you're on a test or if you're somewhere where you don't have the answers. Rewrite the problem again, just on a blank piece of paper, on a scratch piece of paper somewhere. Redo the entire problem. Do not look at the problem you just did and see if you get the same answer as what you did. I like to do this strategy after you've done like the whole rest of the assignment. So don't do one problem and then do it again. Do the one problem, do all of the work, in fact. And then when it's time, before you turn it in, and it's time to kind of check your work, then you look at a problem and you're like, ugh, I don't know if that's right. I'm going to try it again. Then you redo the problem to see. That gives your brain a little bit of a break between your two attempts to see if you get the same answer. Okay, so then compare those answers. Another thing you can do is ask yourself, does the answer make sense? If I was doing this division problem, 2.1 times 7.9, and I figured the answer is 1.659, 659 10,000ths, I would look at that and be like, how in the world did I get 1 for an answer when I'm basically timesing 2 times 7, and 2 times 7 is 14? My answer should not be 1. It should be something more than 14. And then you can be like, oh, I think I didn't put my decimal in the right spot. It would make more sense for my answer to be 16 and 59 hundredths than just 1. 16 is way closer to 14 than 1 is. So check your answer and be like, does that make sense with what is going on? Okay. And then last thing, another strategy that I like is to reword problems to make sure you understand what's going on. So I look for numbers that are written as words, and then I can just change that into a number so then I can see the numbers, right? And I make sure that when I get my label and when I get my final answer, I'm like, wait, what was the question? And I'll reread the question again. How many cups of water did he drink? And then does my answer make sense? Does it even have like cups as my label, right? I also like to explain the problem in my own words. Let me show you what I'm talking about that. Here's that Sally problem from earlier. Sally and her friends have a bag of candy with 24 pieces of candy. They decide to share the bag equally. If they each get 6 pieces, how many friends are there altogether? So then I'm going to take a step back and I'm going to say something like this to myself. All right, so Sally has some friends and she's sharing candy with them. She has 24 total pieces of candy. And if each friend gets 6 pieces, she must have like more than one friend, right? If you only had one friend, then that one friend would get all 24 pieces of candy, correct? So she must have more than one friend, but not like a ton of friends, right? Because if she had 24 friends, then each friend would only get 1 piece. And it says right here that each friend gets 6 pieces, okay? So she's sharing, and sharing usually means we divide. So this must be a division problem. If I go 24 divided by 6, I get 4. And the question is, how many friends are there altogether? Yeah, it makes sense that there would be 4 friends altogether if she has 24 candies and each friend is going to get 6 pieces. So that's another strategy right there that you can use to help you understand and not make conceptual or computation mistakes, right? So as a review, 3 types of mistakes. Careless mistake is just when you're going too fast or too sloppy. Computation mistake is when your computer, part of your brain, makes a mistake, either adding, subtracting, multiply, or dividing. Conceptual mistake is just when you have like no idea where to even start or what to do or how to set it up. Those are conceptual mistakes. Use your notes to work out the rest of this lesson, and it will help you understand even more as you practice through it. See you guys later.